Useless. Hello everyone, very good morning. Welcome back to Express VTU for all. I hope you are doing well. Those who are joining right now, please comment your. So guys, today live class is very important one. This is complete quick revision, doubt clearing session for VTU third semester BCS 301. I know exam are today, so syllabus is big, time is less, and that exactly why this class is happening. I know this is a live class. We are doing not learning theory. We are just focusing on important formulas, exam oriented numericals, typical VTU questions, and your doubts. So if you have any doubt, please comment here. I will solve it. I will revise all modules quickly, tell you what to study, what to skip, and how to write answer in exam so that you can score maximum marks. Very important, very important thing is that keep your doubts ready. Ask them in the live chat. I will give answer of each and every question, and I will solve it here. If you are serious about clearing VTU maths this semester, then stay till the end of this live class. It will really help you. And also, if you have not subscribed to the channel yet, please subscribe Express VTU for all and like them live stream. It motivates me to bring more revision session like this. So all right, let's not waste time. We will start from module 1. I will give you a quick revision from module 1. If you don't share your channel, if you don't share my channel, please share it among with your friends. We will wait after 5 minutes, and after 5 minutes we will start. So guys, please share among with your friends. We will wait just for only 2 minutes. After that we will start. And whatever your doubts from module 1 to module 5, please comment here. First we are working on module 1 and explain each formula and concept. So if you have any doubts from module 1, please comment here. I will clear it. So now let's start. So first we understand from module 1 expectations of discrete random variable. This is a very important topic which many times asked in VTU examination. And I will tell how we can solve these kinds of problems and formula also. So first we understand from module 1, which is expectation. It means mean of discrete is nothing but different data, discrete random variable. So what is the formula to find the discrete random variable? So here we write the formula, which is nothing but expectation for x equals to summation of x. This is nothing but p of x, which is the table is given here. So let's take an example for better understanding. Example, if x some random variable given here 1 comma 2 comma 3 and p of x is given here like that 0.2 probability at particular value of x like that 0.5 comma 0.3. So how can you find the expectation of x, which is nothing but expectation of x equals to 1 into 0.2 plus 2 into 0.5 plus 3 into 0.3. So 1 multiply 0.2 plus 2 multiply 0.5 plus 3 multiply 0.3. So when we solve it, it becomes 2.1. So expectation of x equals to 2.1. Like that in the examination, just like given this a table and we have to find the expectation of x. So by this formula, you can easily find the expectation of x. So now move to our second topic where we are finding variance of discrete distribution. Our second topic from module 1, which is variance of discrete distribution. So how can we find the variance of different discrete variance, which is variance of x equals to expectation of x square minus expectation of x whole square. So already we calculate expectation of x, which is nothing but square the x value and multiply our probability of x, which is given here. So it means 1 square multiply expectation of 0.2 plus 2 square multiply 0.5, 2 square multiply 0.5 plus 3 square multiply 0.3. So 3 square multiply 0.3 . So when you add it, it becomes 5.1. And already we know that the expectation of x, which is equals to 2.1. So variance of x equals to 5.1 minus this is nothing but expectation of x, which is 2.1 whole square, this square. So 5.1 minus 2.1 whole square. So when you solve it, it becomes 0.65. So this is nothing but variance of x equals to 0.65 in terms of discrete distribution. One of the student comment is how can we find variance in first module. So variance is nothing but the discrete table is given here, which is variance is equals to expectation of x square. X square nothing but the table which is given here. It means 1 2 3. First we square this one and multiply the p of x, which is given here. The formula is to find this one is variance of x equals to expectation of x square minus expectation which is given here to the whole square. So first we calculate this expectation, after that you square one, you can easily calculate the variance of x square in terms of discrete distribution. Like that you have to solve it. Or if you want to, for better understanding, you can type it for the in table form like that x particular value of 1 2 3 and p of x equals to, I'll give you an example. This is x and this is p of x. Sorry, this we are taking this one. So this is 1 2 and 3. Particular value is 0.1 at x equals to 1. This is 0.5 and this is 0.3. So first we find expectation of x square is nothing but square this value and multiply p of x. So 1 square into 0.2, that's why I am using here like that. 2 square into 0.5, 2 square into 0.5, 3 square into 0.3. So 3 square into 0.3. And what will be the formula to find expectation of x whole square, which is 1 into 0.2 plus 2 into 0.5 plus 3 into 0.3 plus. So when you add it, it becomes 2.1. And after that, if you find expectation of whole square, you can square 2.1 square. That's why I'm using this value here. Like that you have to find. Sorry for the inconvenience. Actually, the network issue is there. That's why. So one of my students, Sovani, asked one question, which is f comma y, probability distribution of x and y is given by f comma y, which is equals to 30 square. For x equals to 0, 1, 2, 3, y equals to 0, 1, 2. So in this part, two question is there. First part is probability where x is greater than 2, comma y where less than or equal to 1. In second part, probability where x is less than or equal to 2 and y equals to 1. So let's solve this question. F of x comma y equals to 30 square for x equals to 0, 1, 2, 3 and y equals to 0, 1. So 13 square cannot be probability mass function. So it is a constant greater than 1. So something is missing or mistype. Please correct it. So first what I will do after this, once you confirm the function, I will full solve it. Probability where x greater than 2, y less than or equal to 1. First part in this question is, and second part is probability where x greater than y. So please dear, correct this question. This is not 13 square there. Please correct it. Am I audible to you? I think you type here 30 square. I think this is wrong. Okay, I got your questions. So let's solve it, this question. It's asked by one student. So first we write what is the given function f comma y which is equals to x plus y by 30. What is the value of x which is given in this question? X equals to 0 comma 1 comma 2 comma 3 and y equals to 0 comma 1 comma 2. So first we, what is our first step? First step is optional check, means what are the options which is given, it is correct according to the condition or not. So summation of x and summation of y, x plus y equals to 30. So we can say that summation of function of x comma y equals to 1. Up to here I think you understand it. So this is a valid point. Now we have to go over part by part. So our first part is probability where x is greater than 2 and y less than equal to 1. What are the values satisfies this condition? It means if x is greater than 2, what are the value of x? It is equals to 3 because x value is greater than 2. And for y less than equal to 1, it means y should be 0 comma 1. So we have to find the probability of f3 comma 0 plus f3 comma 1. This is 1. So what the value of 3 comma 0 is nothing but 3 plus 0 divided by 30 plus, and what is for 3 comma 1? 3 plus 1 divided by 30. So when you solve it, it becomes 3 by 30 plus 4 by 30. It becomes 7 by 30. This is our first part where we probability x greater than 2 comma y less than equal to 1, which is equals to 7 by 30. So I think up to here you understand it. This is our first part. Now move to our second part. Please do the comment if you have more doubt. So our second part is, am I visible or audible to you clearly or not? Please comment. Guys, am I audible to you or not? Please comment. So our second part is P where x greater than y. So for possible pairs of x greater than y, so what are the possible pairs where x greater than y? It means if y equal to 0, x should be 1 comma 2 comma 3. Here our x is greater than y. Sorry, our x is greater than y. Yes. Now in second part, if y equals to 1, then x should be 2 comma 3. Like that, for y equals to 2, x should be 3. So let's solve it. Probability where x is greater than y, it means summation of function which is f comma y. So we have to add 1 by 30 plus 2 by 30 plus 3 by 30 plus 3 by 30 for the second function plus 4 by 30 plus 5 by 30. So when you solve it, it become 18 by 30. So you minimize this become 3 by 5. So what is probability where x is greater than y which is equals to 3 by 5? I think you understand this question. I'll solve two parts which is asked in this question. Comment, understand or not you? Now you understand this question or not? Please comment. Am I audible or visible to you or not, guys? Now we are moving our second topic from first module, which is So one more part is there, I think. Probability where x is less than equal to 2 or y equals to 1. So let's always have a third part. So guys, please comment audible or visible. So our third part, probability where x is less than equal to 2 comma y equals to 1. So what are the values we are taking here for this condition? Values, it means x equals to 0 comma 1 comma 2 and y equals to 1, because our x is less than equal to nothing. It means we can take it 0 value, 1 value or 2 value, because x is less than or equal to 2 is there. So we are finding the probability where function of 0 comma 1, this is nothing but x value and y value, plus 1 comma 1 plus 1 comma 2, up to where we take it value. This is nothing but 1 by 30 plus 2 by 30. Sorry, here this is 2 comma 1, because x value is 2 and y is always same, which is equals to 1. And this is nothing but 3 by 30. So when you solve it, it becomes 6 by 30, which is equals to 1 by 5. So our probability where x is less than or equal to 2 or y equals to 1, which becomes 1 by 5. This is our third part. If you have any doubt like this, you can ask and comment here in the comment box. So I think this question is clear to you. So now move to our second important topic from module 1, which is nothing but standard deviation. Is standard deviation. So standard deviation is nothing but under root of variance. So from first question what I solved, the variance of value which is equal to 0.69. So how can you find the standard deviation? Standard deviation is nothing but under root 0.69. So when you solve it, it become Am I audible to you guys? Please comment. It become nearly 0.83. So now we are moving our second part where we have to find the unknown constant k value in unknown constant k. So in this nothing but one more condition is there for finding the value of k. We already know that this is the condition, sum of probability which is equals to 1. Already we know that if the table is given like that, x value is there and particular x value, some probability is there. So summation of x is nothing but equals to 1. It means for x equals to 0, 1, 2, 3, and p of x equals to like k, 2k, 3k, and 4k. So already we are using this formula where k plus 2k plus 3k plus 4k equals to 1. So when you add it, it becomes 437 or 29110. So 10k equals to 1 and k equals to 1 by 10. And that's why this way you can find the probability, this condition using. So now we are looking for another important topic, which is nothing but binomial probability. Binomial probability. If you have any doubt regarding this constant k, how can we find? Please ask here. So our topic is binomial probability. So what is the formula? First we understand the formula. Probability where capital X equals to small x. This is nothing but at what cases we have to find the binomial probability, which is equals to ncx p to the power x q to the power n minus x. This is nothing but probability of success. This is nothing but probability of failure. And this is the n value which is given here. Let's take an example for the better understanding. If one coin is tossed 9 times, it means n equals to 9, and probability of getting head is 2 and tail is 3. So what is the value of n? N is 9, or p value is 2. And if you know p value, you can easily get the value of q. So like this question, you have using this formula, and in place of small x, you can using the value which is given here, like 2. So this is the formula for binomial probability. Let's take an example for better understanding. If a coin tossed 4 times, if a coin tossed 4 times, find probability where 2 head is there. So how can we find? Already we know that probability of 2 means small value of x equals to 2. So we have to find probability of 2, which is equals to, what is the value of n, which is nothing but 4. C, x value is 2, p to the power x means, already we know that head equals to 1 by 2, p equals to 1 by 2, and q equals to 1 minus 1 by 2, which is equals to 1 by 2, because we know that p plus q equals to 1. This identity we are using here. So 1 by 2 to the power x, which is nothing but 2, and q is 1 by 2 to the power n minus x. N value is 4 here, and 4 minus 2 equals to 2. So probability of 2 equals to 4c2, 1 by 2 to the power 4, because 2 to the power 2 and 2. So like that you have to solve in the examination. First understand the question, what it asks. So like that you have to using this formula. This is a very important formula you have to remember from module 1. If you have any doubt regarding this, please comment from module 1. I will explain. If you have any doubt, any question regarding this module 1. Am I audible to you? Share among with your friends. Now we understand our next topic, which is mean of binomial distribution. So our next topic is mean of binomial distribution, which is nothing but mu equals to np. This is nothing but the value of n, means if the coin is there, so how many times the coin is tossed. This is nothing but n, and p is probability of success. So our next important formula, which is variation of binomial distribution. Variance of binomial distribution, which is nothing but sigma equals to under root npq. This is the formula for finding the variance. You have to understand it. Now one more important formula from module 1 is Poisson's probability. Here we write Poisson probability. So this is a very important formula you have to remember from module 1. So this formula is P of x equals to small x, which is equals to m to the power x e to the power minus m by x factorial. M is nothing but mean is here, which can be represented it as m equals to np. So this is a very, very important formula you have to remember. Let's take an example for this for better understanding. This is the example. If mean defect m equals to 3, find probability. It means if mean defect m equals to 3, find probability of 0. It means we can clearly see that our x value is here 0. So if we put value x equals to 0 in this formula, it means p of 0 equals to m to the power 0. So m to the power 0, e to the power minus 0 divided by x factorial is 0. So this is nothing but here e to the power m is there. So if anyone has power 0, it means equals to 1. So probability of 0 equals to nothing but e to the power minus m. Like that, we have to find at what condition we have to find the probability distribution. Now we have to remember one more important formula from model 1, which is nothing but mean and variance Poisson, which is nothing but mu equals to sigma square equals to m. This is the relation you have to remember in the examination. Now this is here our first module is completed. If you have any doubt regarding from first module, you can comment here. I will solve it. You guys understand this or not? Every concept is clear from module 1. Clear or not? Please comment if you have any doubt regarding from module 1, any question from module 1. I will solve it. And please share among with your friends who have today exam. So let's start our module 2. Module 2. So our module 2, first important points from module 2 or important concept from module 2, which is nothing but joint probability distribution. So joint probability distribution. So what is the condition for this condition? It means summation of x to summation of y is nothing but this is a function of x, comma y, which is equals to 1. This is the condition for joint probability distribution. Example, we are taking an example for the better understanding. If probabilities, joint probabilities are given, if joint probabilities are k, 3k, 2k. So we are using this condition, which is k plus 3k plus 2k, which is equals to 1. So when you add it, it becomes 6k equals to 1. Then what is the value of k? K is nothing but 1 by 6. So this is nothing but summation of x into summation of y of function x, which is equals to 1. Now clear, I think. One of the student told about M4 module, I think. So we will cover it. First we are working on module 2. Later we will cover from module 3 and module 4 also. Now we are looking for another important topic from module 1, which is marginal probability distribution. So our second important topic is marginal probability distribution. So guys, I think of VTU math, every module is contain equal mass. From module 1, I think 20 marks, 20 from module 2. So we will concentrate on module 2 right now. After that, we will concentrate on module 3, module 4 and module 5. So our important topic from module 2, which is marginal probability distribution. So what is the formula? F of x is x equals to summation of y function of x comma y. Like that for y, f of y small y, which is y equals to summation of y, the function of x comma y. This is the discrete marginal probability distribution for x and y. So now let's take an example for better understanding this marginal probability distribution. So now take an example. This is a x comma y. This is 0 1 and 0 1. At 0 value is 0 0.2, 0 0.3, and for 0 0.1 and 0 0.4. So first we find f of function x at equals to 0, which is equals to 0 0.2 plus 0 0.1. 0 0.2 plus 0 0.1 at 0 for x, and for y for 1, which is equals to 0 0.1 plus 0 0.4. It means y of 1, which is equals to 0 0.1 plus 0 0.4. So 0 0.1 plus 0 0.4, which is equals to 0 0.5. So this is how we use the formula in the given question. So now we are looking for another important topic, which is expectation of two random variable. So expected of two random variable. Up to here, I think you guys understand it. If you have any doubt regarding from this formula, please comment. Have you any doubt? Please comment, guys. Okay, clear. So first we write the formula. For expectation of x, our formula equals to summation of x into f of x. Like that, for expectation of y is nothing but summation of y function at y equals to y. So this is the formula for expected of x and y. So let's take an example from this table, which is first we find expectation of x, which is equals to 0 into 0 0.3, means 0 0.1 plus 0 0.2. It means 0 into 0 0.2 plus 0 0.1 plus, for 1 is 0 0.3 plus 0 0.4. So 0 0.3 plus 0 0.4. Then this becomes 0 plus this become 0.7. So this is nothing but expectation of x equals to, this is expectation E, sorry, which is 0.7. Like that, you have to find the y also. Now we have to find another topic, which is expectation of x and y. It means expectation of product, which is nothing but expectation of x of y. Here we are calculating separately expectation. Here we are calculating expectation of x and y both. So expectation of x into y, which is equals to summation of x into summation of y, which is x comma y, and the function which is given to x comma y. This is the formula, and this is the expression. We have to find expectation of x and y both at the same time. So let's take an example. Same example we will consider, and we will just calculate. So expectation of, this is expectation of x and y, which is equals to 0 into 0 0.2 plus 0 into 0 0.1 plus 0 into 0 0.3 plus 1 into 0 0.4. So when you calculate it, it becomes 0 0.4. So this is our expectation of x, y, which is equals to 0 0.4. We consider only same example for both this question. to here clear, guys? If you have any doubt regarding this, you can ask here. Or if you want any question or any topic, please comment here. I will explain it. Am I audible to you? Clear? Now we will move another important topic, which is variance of x and y. So variance of x and y. So what is the formula of variance of x and y? Formula, which is variance of x equals to expectation of x square minus expectation of x whole square. This is the formula for variance. And what is the formula of correlation? Correlation formula, which can be represented it as rho of x comma y equals to covariance of x comma y divided by sigma of x into sigma of y. This is nothing but expectation of x and expectation of y. This is a very important formula. Many times asking VTU examination. For using this formula, we have to calculate one question. It is compulsory come in this exam. So you have to remember this all the formula from module 2. Please comment if you have any doubt regarding this module 2. I will solve it right now. Otherwise, we will move from module 3. If you have any doubt regarding from module 2, you can comment here. After that, we will move for module 3. So here I am explaining one more important topic, which is related to Markov chain or stationary steady state. So Markov chain, or which is, we can say that this is a transition matrix condition. It means where row sum equals to 1. This is the condition for Markov chain. Let's take an example for better understanding. Example, this is a matrix which is given here, which is 0.6, 0.4, and this is 0.3 and 0.7. So as you can clearly see that if you add 0.6 plus 0.4, it should be equal to 1. 0.3, 0.7, it should be equal to 1. So this is the condition for Markov chain. While solving this type of question in the examination, you should remember this important thing, which is row of sum equals to 1. Now move to our one more important thing, which is stationary steady state. Stationary steady state. So what the condition for this? Vp equals to V. V is nothing but our given assumption matrix, which is x comma y, and p is a function which is given in this question like that. This is given as 0.6, 0.4, and 0.3, 0.7, like that. So you have to multiply v by p, which is equals to v. So you are using this condition for steady state or stationary. So here our second model is completed. If you have any doubt regarding this, please comment in the comment box. I will solve it. Am I audible to you? If you have any doubt regarding this, please comment. Otherwise, we will move to model 3. Am I audible to you guys? So now we will move over module 3. So we are taking an example and understand every and each formula from module 3. So we are considered a problem. The problem is a random sample of 900 observation has a mean equals to 3. The population mean is 3.25 with an standard deviation equals to 1.61. Test whether the sample comes from this population at 5% level of significance. So we can consider a problem which is a random sample of 900 observation has a mean equals to 3.4. The population mean is 3.25 with standard deviation which is equals to 1.61. Test whether the sample comes from this population at 5% level of significance. So first while solving this type of question we have to understand one condition. So this is the condition and this is the test we are using here while looking for a condition. If n is greater than 30 we are using z test, or if n is less than or equal to 30 we are using t test. So I am explaining z test and t test both formula here. So first we understand this condition satisfy where n is greater than 30. So our n value is 900. So we are using here z test. So let's solve it step by step and we are cover all the formula which belongs to module 3 with the help of this question. So our step 1 is already we identify we are using this formula because our n value is greater than 30. So our sample size where n equals to 900 which is greater than 30 which is large sample. So we are using here z test. Now move to our second step which is step 2, state hypothesis. State hypothesis. It means we consider two hypotheses. First one is alternate hypothesis and second one is null hypothesis. So our alternate hypothesis can be represented as h naught which is mu equals to 3.25 which is given in this question, and h1 which is alternate hypothesis where mu not equal to 3.25. This is the condition for hypothesis. Null hypothesis always equals to 1. So null hypothesis always represent as equal because it satisfies the condition for null hypothesis. If it not equal to, it means this is the alternate hypothesis, like that. So now we will move our step 3, where we are finding standard error mean, which is nothing but SE. So in step 3, we are finding standard error of mean. Standard error of mean, which can be represented as SE. So what is the formula? SE equals to sigma y under root n. Sigma already given in this question, which is nothing but 1.61. So we can put the value in this formula. You can easily get the standard of the mean. What is the meaning of standard error? Standard error tells how much the sample mean fluctuate from the population mean. This is nothing but the standard error. Now we have to calculate. This is nothing but 1.61 and n value is 900. And to solve it, it become 1.61 divided by 30. So our standard error equals to 0.0537. So like that you have to find. Now we have to calculate the test statistics. So our step 4 is calculate test statistics. So what the formula, which can be represented as z equals to x bar minus mu by SE. SE is nothing but our standard error. It what it means? It measures how far the sample mean is from the population mean in SE unit, means standard error. So now calculate it. Z equals to x value given in this question, which is 3.4, minus mu value is also given in this question, which is 3.25, minus standard error we calculate, it is 0.0537. 0.0537. When you calculate it, become 2.8. So our z value is 2.8. What is the critical value at 0.05% for z? Z 0.05, which is equals to 1.96. So we can clearly see that 1.96 is less than 2.8. It means our given z value, this is given value, is less than our z calculate value. So here we reject our null hypothesis, which is represented as h0, and here our h1, which is alternate hypothesis, accepted here. This is reject. Like that you have to solve in the examination to get the full marks. So what is the final conclusion? While solving these kinds of question, you need to remember an important point. You have to write the final conclusion to get the full marks. So we can say that the samples does not belong to the condition which is given here. It means it should be less than equal to, not equal to, it should be less than the calculated value. Then our null hypothesis accepted. Otherwise, our null hypothesis rejected, like that. So one more important formula from module 3, which is confidence interval. What it is? X bar plus z at 0.05 into SE. SE is nothing but our standard error. X bar already we know, which is nothing but 3.4. Z value 0.05, which is equals to 1.96. This is a fixed value. No need to worry about it. Your formula book is given in the examination, so you can see from this. Now, what is the value of standard error? Which is 0.05. So when you put, you can easily calculate the confidence interval, which is comes in like this, is considered as x and y. The formula comes in this form, your answer, because plus minus is there, sorry. So like that you have to solve in the examination to get the full marks. So here our third module is completed. If you have any doubt regarding from third module, you can ask, I'll solve it. If you have any doubt regarding this, you can ask it from module 3. I will solve it. If you have any problem, any question from module 3. So now we will move our module 4. Module 3 and module 4 approximately same formula is there, but the concept little bit different. So our for module 4, we are using one sample test. So our one most important topic is one sample test. So what is the formula? We are using a T formula, which is T equals to x bar minus mu by s by under root n. This is the formula for calculate T statics. We can consider data for this. X bar equals to 74.5, mu equals to 7.5, 47.5, sorry, and s equals to 2.41 and n equals to 10. So now put all the data in this formula. So t equals to x bar is nothing but 74.5 minus 47.5 divided by s value is 2.41 under root 10. So when you calculate it become 1.827. So this is the data I'll take from one question in this examination. It is asked out at what percent we have to find, like at what significance level. It means 1%, 5% we have given in this question. So you have to calculate according to this condition, and I already told you where we have to calculate T statics and Z statics from module 3. Now one more important formula from this module 4, which is paired T test. Paired T test, which is nothing but T equals to dy sd under root n. So our d is nothing but mean difference, which is given in this question. So this is a very important formula from module 4. You have to remember it. And for two sample, what is the formula of T test? For this is one more important, for two sample, it means two sample are given in the question. How can we calculate T statics? Which is nothing but T equals to x1 bar minus x2 bar divided by under root s square y 1 by n1 plus 1 by n2. This is the two sample which is given in the question for different mean. So this is one more important formula. Now move to another important formula from module 4, which is chi-square or test, or we can say that this is goodness for fit. So one more important formula, which is chi-square test, or we can say that goodness for fit. So this is one more important formula from module 4, which can be represented as chi-square equals to summation of O minus E square divided by E. This is nothing but E is the expected frequencies and O is observed frequency. So let's consider for better understanding. Example, whatever observed frequency which can be represented as OF, which is 15, 6, 4, 7, 11, 7. 17 we can consider this, and our expected frequency which is equals to 10 comma 10 comma 10 comma 10 comma 10. Why I'm consider same? Because for the better calculation or easy calculation. So when you put all the values in the formula one by one, first you consider this given data into the tabular form. It means observed frequency, expected frequency, O minus E and O minus E square. I can show you. You can consider first in the form of table. It means observed frequency, expected frequency, O minus E and O minus E square, like that. So when you solve this, it become 13.6. This is nothing but our chi-square. This is one more important formula. And when you compare the F test, means you have to compare equality of the variance. Equality of variance. So what is the formula? Which is F equals to larger variance divided by smaller variance. Smaller variance. This is the one more important formula from module 3. Up to here, if you have any doubt regarding this, please tell. Here our fourth module is completed. Important formula and important concept is there. So guys, am I audible to you? If you have any doubt regarding from module 4 or 1, 2, 3 up to 4, if you have any doubt, you can ask here, I will solve it. After that, we will move to our module 5, which is our last module. If you have any doubt, please comment. I think all are clear. All concepts are clear. Okay, move to module 5, sir. So we are moving our module 5, which is one-way ANOVA, two-way ANOVA, and latent square. These are the three important topics which comes in module 5. So we are taking one example, and for that example, we are solving each part. So first we consider for one-way ANOVA. One-way ANOVA. So three machine A, B, C are used to produce items. The outputs are, so we are considered A, B, three machines, and outputs are given here. This is A, B, and 3 C. These three machines we are considered. This is 5, 6, and 7. This is 7, 8, 9, 6, 5, 7. So I can write this the given data in the tabular form. And the question is asked about test whether the machines are equally effective at 5% level of significance. And the question is asked about at 5% level of significance the machine is effective or not. So first we consider the hypothesis. It means we consider null hypothesis, and H1 is alternate hypothesis. So what is considered in this question? Alternate hypothesis is nothing but at least one machine different from the other machines, or in null hypothesis all machines are equal. It means all machine perform the task, all machine produce the items equally. This is for null hypothesis. And if one machine different produce item from other machine, it comes in alternate hypothesis. So what are the, this is our step 1. In this module, we have to solve each problem step by step to get the full marks. So our step 2 is step 2, sum of square for the given data. So how can we find the sum of square? First we find the total. Total equals to 5 plus 6 plus 7. 5 plus 6 plus 7 plus 7 plus 8 plus 9 plus 6 plus 5 plus 7. So when you add it, it becomes 60. And what is the value of capital N? This is nothing but total number of observation, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is there. And what is our column? C equals to 3. 1, 2, 3 columns are there. So now we are calculating our sum of square for each. First we are calculating for column SSC, means sum of square due to column. So what is the formula to find? This is nothing but 18 square divided by 3 plus 24 square divided by 3 plus 16 square divided by 3 minus CF. CF is nothing but our correction factor. So what is the formula to find the correction factor? CF equals to T square by capital N. T square is nothing but total, which we are finding 16 square, and N is number of observation, which is 9. This is nothing but total number of observation. So this is the formula to find, which means 60 square divided by capital N is 9. So like that you have to solve the correction factor. So first we square the 5 plus 6 plus 7, means it means 18. So 18 square divided by 3 means how many rows are there? 1, 2, 3 rows are there. That's why we are dividing 3. In terms of rows, we are dividing the column. How many columns are there after adding the row value? So here our sum of square due to column is completed. Now we have to find sum of total. It means total sum of square. So SST, it means summation of x square minus CF. CF is the correction factor, which is equals to T square by capital N. What is the summation of x square? Which is nothing but 5 square plus 6 square plus 7 square plus 7 square plus 8 square plus 9 square plus 6 square plus 5 square plus 7 square. This is nothing but summation of x square minus CF is nothing but 60 square by 9. This is our sum of total. Now we have to find the mean square in one way ANOVA. So our step, I think I am visible or not? Comment. Step 4, we are finding mean square for one way ANOVA. Mean square. So what the formula of mean square? MSC means mean square of column is nothing but sum of column divided by degree of freedom, which is nothing but C minus 1. For column, we find the degree of freedom, which is equals to column minus 1, and for row we are finding degree of freedom, which is equals to row minus 1, and for error we are finding C minus 1 into R minus 1. This is nothing but degree of freedom. You have to remember these important points. So like that you have find the mean square. And what the step to find the step 5, which we find the F ratio. So how can we find the F ratio? Which is nothing but F equals to mean square of column divided by mean square of error, MSE. So this is the formula to find the F ratio. So what are the value we are getting from F ratio? We are compare this to the given value. Hi Vishal King. If you have any doubt regarding this, you can ask here from module 1 to module 5. So now we are looking for our two-way ANOVA. Two-way ANOVA problem. So we are consider one another table or another question for two-way ANOVA. The following table shows yield under 3 fertilizer and 3 field. So this is our field 1, this is our field 2, and this is our field 3, and this is nothing but our fertilization 1, 2 and 3. This is 8, 9, 10, and this is 7, 8, 9, and this is 6, 7 or 8. So like from our first one way ANOVA problem, we are considering our first one is step one is hypothesis. We consider two hypotheses. First one is alternate hypothesis and second one is null hypothesis. So our step one hypothesis, which is H0 is null hypothesis and H1 is alternate hypothesis. So here row and column both are given, row for field and column for fertilization. So if these two are equal, then we consider that it is null hypothesis. So what are the step 1 is completing here. Now move to our step 2. Step 2 where we finding the total. Total is nothing but 8 plus 9 plus 10 plus 7 plus 8 plus 9 plus 6 plus 7 plus 8, which is equals to 72. So our total equals to 72. And what is the R value? R value equals to 3, which is 1, 2, 3 rows are there, and column value is 3 also because 1, 2, 3 columns are there. So C equals to 3. And what is the value of capital N, which is nothing but total number of observation, which is equals to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the total number of observation. So what our step 3? Our step 3 where we are finding the correction factor. Correction factor, which is nothing but CF. So what is the formula to find the correction factor? CF, which is equals to T square by capital N. T is nothing but total, which is equals to 70 square by capital N is nothing but observation, which is 9. So this is the formula to find the CF. Like this you have to find in the examination. Up to, if you have any doubt regarding this, please comment. Now move to our step 4. So our step 4 is sum of square. Sum of square. Here we are finding first one is total sum of square, which is nothing but SST equals to summation of x square minus CF. It means square 8, 9, 10, after that you add it. Like that you have to find the summation of x square, means summation of each value of x. And correction factor is T square by capital N. And now can you find the sum of square due to row, which is equals to summation of row total square divided by column, which is nothing but 3 minus CF. This is for sum of square due to row and sum of square due to column, which is nothing but summation of column total square divided by row minus CF. This is the formula for sum of square due to column. If you have any doubt regarding this, I can solve it to take the value. I am writing here row and column for the better understanding. Now move to our third part where we find the F ratio. So our step 5, we are finding our F ratio for the two-way ANOVA. So for we are finding, no need to confuse in two-way ANOVA, one-way ANOVA, because in one-way ANOVA we are finding mean ratio, mean square for column, only column are there, or we can say that row are there. But in two-way ANOVA we have to calculate for the column and row also F ratio. So F ratio for column, which is equals to mean square of column divided by mean square of error, and for row, mean square of row divided by mean square of error. So in both, the denominator is same for calculating the F ratio. This is the formula. So like that, you have to write in the examination, and you have to compare the table value which is given in the question to accept the null hypothesis or reject the null hypothesis according to the given value in the question or calculated value. So now we are moving our last step from module 5, which is nothing but latent score design. If you have any doubt regarding from module 5, you can comment here. I will solve it. Any doubt from module 1 to module 5. Please comment. Am I audible to you? All clear from module 1 to module 5? If you have any doubt regarding this, please comment here. So now move to our last topic, which is latent score design. One of the student asked P. Raja K. Sir, please explain the latent score problem. Okay, I'll explain it by taking an example. First, we understand what is latent score design. A latent score design is used to when three factors affect the result. First one is treatment, second one is row, and third one is column. Each treatment appears once in every row, once in every column. This moves the effect of rows and column. When do we use latent score design? The number of treatment equal to number of rows equal to number of column. In this case, we are using latent score design. It means, let's take an example. 4 fertilizers are there, 4 fielders there, and 4 seasons are there. So we are consider one problem regarding this. So here we are consider one example for latent score design. This is nothing but row 1, row 2, row 3, and row 4. This is column 1, column 2, column 3, and column 4. This is consider data which is A, B, C, and D, and this is B, C, D, A, C, D, A, B, and D, A, B, C. In place of A, B, C, D, you can consider any value, but I am explaining just the concept. How can we calculate the latent score design? So we can solve it step by step. What is the first step? We are considered for one-way ANOVA, two-way ANOVA, and latent score design. Our first step is same for all these three problems. Means our first step is hypothesis. We are considered two hypotheses. First one is null hypothesis and second one is alternate hypothesis. It means all varieties are equally effective. Here our alternate hypothesis is rejected. Here at least one variety is different. It means our alternate hypothesis accepted. And whatever step 2, we find the total and correction factor. So for better understanding, we are consider A, B, C, D value. So for A, we consider 8, B consider 6, C consider 5, and D consider 7. Like that, B consider 7, C consider 7, D consider 6, and A consider 6. And for C consider 6, D consider 8, A consider 7, and B consider 5. And for D, we consider 5, A 5, B 8, and C 8. For the better understanding, we are consider one value. Now let's solve it step by step. So our t value, which is nothing but addition of all these things: 8 plus 6 plus 5 plus 7, 7 plus 7 plus 6 plus 6 plus 6 plus 8 plus 7 plus 5, 5 plus 5 plus 8 plus 8. When you add it, it become 1044. This is nothing but our total, and n value is nothing but total number of observations, which is equals to 16. It means 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So our total number of observations, which is n equals to 16. So how can we find the correction factor? CF equals to t square by capital N. T is nothing but 104 square by capital N is 16. So when you solve it, it becomes nearly 676. This is nothing but our correction factor, which is equals to 676. Now move to our step 2, where we are finding sum of square. So in sum of square, we are finding 4 cases, and one more case is added, which is error sum of square. So first one is total sum of square, second one is row sum of square, third one is column sum of square, and fifth one means treatment sum of square. So step 3, we are finding sum of square. In step 1, we are considering our null hypothesis. We are considering our hypothesis, which is null hypothesis, and accept alternate hypothesis. In step 2, we are calculating our total, and in step 3, we are using sum of square, means we are calculating sum of square. So first we understand how we calculate total sum of square. Total sum of square. So what is the formula? Which is SST equals to summation of x square minus CF. CF is nothing but our correction factor. How can we find the summation of square x square, which is nothing but square every observation, and after that you add every observation and subtract correction factor from our observation. This is for total sum of square. Now we have to find row sum of square. Row sum of square, which is nothing but SSR equals to summation of r square by 4. How many columns are there? 1 2 3 4 columns are there. That's why I am dividing 4 minus CF. This is for calculating sum of square for row. Now we have to find column sum of square, which is SSC equals to summation of column square divided by 4 minus CF, because 4 rows are there. 1 2 3 and 4 rows are there. That's why I am dividing 4. This is the formula to find the column sum of square. Now we have to calculate treatment sum of square. So treatment sum of square, this is nothing for the varieties, means SSV equals to summation of v square by 4 minus CF. CF is nothing but correction factor. This is the formula to find treatment sum of square. And what? How can we find the error? SSE sum of error, which is equals to SST minus SSR plus SSC plus SSV. So you have to calculate each value 1 2 3 4 and subtract from our total to find the sum of square. Like that, you have to find sum of square for each cases. And after that, in step 4, we are finding step 4, we are finding our degree of freedom. Degree of freedom. So how can we find the degree of freedom? This is nothing but the source which is given there in the question, and this is nothing but degree of freedom. So first we find the degree of freedom for the rows. What is the formula of find degree of freedom for the rows? Which is nothing but n minus 1. N is nothing but total number of n, which is 1 2 3 4. 4 rows are there. So 4 minus 1, which is equals to 3. And for column, C minus 1, which is nothing but how many columns are there? 4 columns are there. So 4 minus 1, which is equals to 3. And how can we find the degree of freedom for the varieties, which is n minus 1, because 4 varieties are there: A, B, C, D. So n minus 1, which is equals to 4 minus 1 equals to 3. And for error, n minus 1 into n minus 2. This is the value for finding the errors in latent square design, which is 4 minus 1 is 3 and 4 minus 1 is 2. So 4 and 3 into 2 equals to 6. And what is the total? It means n square minus 1, which is equals to 15. N is nothing but 4 square minus 1, which is equals to 16 minus 1 equals to 15. This is for total degree of freedom. So now our step 5 is where we are calculating mean square and f test. So what is the formula to find the mean square? Mean square and f test, which is MSV for variety, which is equals to SSV sum of variety divided by degree of freedom for variety, which is equals to 3, and mean square for error, which is equals to sum of square of error divided by 6, which is nothing but degree of freedom for error. After that we have to calculate the f ratio, which is mean square of variety divided by mean square of error. So like that, you have to calculate the f value. After calculating the f value, we have to compare it to the given value of table. If our calculated value is greater than given table value, here we reject null hypothesis. Our calculated value is less than the table value, here we accept our alternate hypothesis. So like that, you have to solve in the examination. Or we can say that latent square design is used when the number of treatment rows and columns are equal and each treatment appears exactly once in each row and column. We accept our null hypothesis. Otherwise, we reject our null hypothesis and accept our alternate hypothesis. So what is our memory trick to find latent square design? Three factors are there. Two factors are there and one factor are there. Three factors it means latent square design. Two factor it means two-way ANOVA, and one factor it means one-way ANOVA. So like that, you have to solve in the examination to get the full marks. If you have any doubt regarding this, you can comment here from module 1 to module 5. If you have any doubt, any question from module 1, module 2, module 3, module 5, please comment there. I will solve it. Please like, subscribe and share among with your friends. And if you have any doubt, please ask. I will solve it. Okay, P. Rajaki, thank you. If you have any doubt regarding from module 1 to module 5, you ask any type of question from module 1 to module 5, any topic, any concept you want, I will explain it. And one more important thing is that in the examination, Markov chain rule 1, sir, please. Okay, I will explain it. Markov chain. First, we understand what is the meaning of Markov chain. A Markov chain is a random process where the future state depends only on the present state, not on the past. This is called our Markov property. Or we can say that a Markov chain is a stochastic process in which the probability of transition to the next state depends only on the present state. I think the definition will get it. If you want, I can solve a question for this Markov chain. I can write an expression for the Markov property. Markov property which is P of x of n plus 1 which is equals to j. Here x of n equals to I and x of n minus 1 which is equals to, we can say that P of x n plus 1 which is equals to j, or x and I equals to I, x of n equals to I. This is the expression for the Markov property. This is the rule, and we can say that future only depend on the present. This line, it means fetch only 2 marks. So if you write this formula in your examination, you will get 2 marks. But if you want question, I can solve it regarding this. Please comment if you want question, I will solve it for this. Okay, I'll solve it one question for Markov chain. Am I audible or visible clearly to you guys? So now let's take an example of Markov chain for the better understanding. We are taking a real life example for the easy understanding and imagination. Suppose a student result status can be, if a student pass, which can be represented as P, if a student fail, can be represented as F. The probability of next semester depend only on current semester result. So we are given a transition probability. It means if student pass now, pass again with probability of 0.7. If fail without, probability is 0.3. If student fail now, pass with only probability 0.4 and fail again with probability 0.6. So I can write the data here for the better understanding. If student passes now, pass again with probability which is 0.7 and fail with probability with 0.3. This is the condition if student pass now. If student fail now, if student fail now, pass with probability which is 0.4. If fail again, probability is 0.6. I think up to here you get it the data what I am writing here. Understand or not? Please tell me in the comment box. So now move to our further information which is given in this question. So for this we have to write the transitional probability matrix, which is nothing but TPM. So in Markov chain we are writing our transition probability matrix which is TPM. So how can we write it? We can represent it as P equals to 0.7 and 0.3. This is pass again with probabilities and this is fail with probability. And if a student fail now, it become 0.4 and fail again. This is for pass and this is for fail. This is our transition probability matrix. What are the condition and what are the rules we have to check? All values should be greater than or equal to 0 and each row sum which is equal to 1. It means if you add 0.7 plus 0.3, it should be equal to 1. 0.4, 0.6, it should be equal to 1. This is the condition for Markov chain. And we have to find the probability vector. It means at what step this data will be considered. So our probability vector, which is nothing but our initial state, which is pi of 0, which is equals to 1 0. This is our initial state where the student is surely passing now. And after one step, it means we have to find pi of 1, which is equal to pi of 0 into p. So what is the value of pi of 0, which is nothing but 1 comma 0. Student pass or fail. This is the probability of pass and this is the probability of fail. So we have to calculate this one. It means 1 comma 0 multiply by 0 0.7, 0 0.3, 0 0.4, 0 0.6. So when you calculate it, it become 0 0.7 comma 0 0.3. This when student pass in next semester, pass is 0 0.3 and fail is 0. Pass is 0.7 and fail is 0.3. So this is for pass and this is for fail. Up to here you can understand this question or not? Then we will move further. You get it, this concept? Okay, now we will move further. Probability, this is for one initial state and this is for one step. Now up to probability after two step. So probability after two step. It means we have to find the probability after two step is pi 2 equals to pi 1 into p. Pi 1 is already we get, which is 0 0.7 and 0 0.3. So 0 0.7 comma 0 0.3, which is multiply by, this is sorry not equal to, multiply by 0 0.7, this is p value, 0 0.3, 0 0.4, 0 0.6. So when you multiply this value, this matrix to this, you get it 0 0.61 comma 0 0.39. So this is the condition where the student pass. This is for pass and this is for fail for second step. So in one more important thing is that in this Markov chain we have to find also the steady state. So what the formula to find the steady state, which is nothing but pi of v equals to pi, and this is considered let pi equals to, we can consider x comma y. So we have to find the value of x comma y with the help of this equation. Up to here I think you are clear. If you have any doubt regarding this, please comment. Up to here clear or not? What is your doubt? You can tell me, I will explain it once more time. Where you have doubt? First you write the formula in the exam. After that you have to calculate at what step it is asking about. It means first step, second step, third step, fourth step. After that you have to write the steady state. Means we are consider one pi. With the help of this we have find the student pass or fail, x or y. So let's solve this for this steady state also. So pi of v equals to pi, and we can consider pi is x comma y. So when you x comma y multiply by 0 0.7, 0 0.3, this is 0 0.4 and 0 0.6, which is equals to x comma y. So when you multiply these two matrices, it become 0 0.7 x plus 0.4y is compared to x, and this is nothing but x plus y equals to 1. So by solving these two equations, you can easily get the value x equals to 0.57 and y equals to 0.43. So we can say that in the long run, the probability that the student passes 0.57 and fail is 0.43 respect of the initial state. So this is for student pass after long run means 4 step, and this is for student fail. So like that you have to solve in the examination for getting the full marks. A Markov chain is a static process in which the future state depend only the present state and not in past state. I already explained this concept through the question. Up to here, if you have any doubt regarding this, the concept is clear or not? Okay, thank you. If you have any doubt regarding from first module to up to 5 module, please comment. I'll explain this concept or take one question example as a. So like that you have to explain each and every topic in the examination. You have to write formula from each one. First you write formula in examination. After that you have to solve the question. And first you write what is given in this question. It gives a good impact for the examination. Please subscribe and comment if you have any doubt regarding this. I'll solve it. Please comment if you have any doubt regarding this. From module 1 to module 5, I'll explain each and every concept here. Please comment. One way ANOVA problem from 5th module. So one of the student asked one way ANOVA problem. Put the latent square table is not given in the handbook, sir. No need to worry about it. You just remind the step what I am going to telling you in the my videos. You go and watch it along with it. I'm going to explain the one way ANOVA problem which you were asked about. In one way ANOVA problem, we have to follow some steps which I am going to telling you. First, one way ANOVA problem is used to test whether 3 or more samples means are equal when there is only one factor affecting the data. It means for machines, teachers, and fertilizer methods. This example for one problem. So what are the steps we need to follow for solving one way problem is, first one is sorry for the network issue. First step is null hypothesis. For one way no. How to find one way to two way. Okay, I'll explain this concept. For one way. So I will explain for one way affecting the result. What are the key features you have to remember in this question? First one is machines, method, teachers, and fertilizers. So compare the yield of these three varieties. For one way ANOVA, we have to remember one factor. It means one factor affect the given problem. But in two way ANOVA, at least two factors affect the result. It means rows and columns, field and fertilizers, workers and machine, methods and teachers. So for one way ANOVA, one features can affect the result, but in two way ANOVA, two features affect the result. This is the difference between the one way and two way ANOVA. If you want, I can solve one problem for each one way ANOVA and two way ANOVA. Please comment. If you want, I can give an example along with this. I think your doubt is clear, Punti. If you want, I can solve one problem for each one way ANOVA and two way ANOVA with a short example. I can tell you a formula. From module 4, I can explain what are the formula which we are using here for one way ANOVA and two way ANOVA. So for one way ANOVA, first we are formula for one way ANOVA. It means first we find the correction factor. CF equals to T square by capital N. T square nothing but total number of observation which is given in this question, means one at A, B, C. Three observations are there. For one values there 1, 2, 3, like there are two values there. So first we add this all this value, and R is nothing but total number of observation, means 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. It means we can consider A, B, C. This is 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is the value of capital N? This is nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 observations are there, so N value equals to 9. And what is T square means? 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 square plus 8 square plus 9 square plus 10 square. After that you add it and put in this formula, you can easily get the correction factor. This is our step 1. Now move to our step 2, where we find the total sum of square. Total sum of square, which is nothing but SST is nothing but summation of x square minus CF. This is the formula to find the total sum of square in one way ANOVA. And our step 3 is sum of square due to column, which is nothing but summation of sample total square for rows divided by n minus CF. And it is nothing but total number of rows is there. It means 1, 2, 3 rows are there. So divided by 3 after squaring each row. This is formula for SSE. Now we have to find in 4 step, which is nothing but sum of square, means SSE equals to SST minus SSC. This is nothing but sum of square of total and sum of square due to column to finding the error sum of square. Now we are moving our 5th step, where we find the mean square. So only one factor is affected there. That's why this is called a one way ANOVA. Means we have to find mean square for the column, which is equal to sum of k minus 1. K minus is nothing but degree of freedom, which is we are finding with the help of mean. And in 6th step, we are finding mean square of error, which is nothing but sum of square due to error divided by n minus k. N is nothing but total number of observation, and k is nothing but total number of rows. Column is there, 1, 2, 3 columns are there. This is for calculating the mean square of error. In 7th step, which is our last step, where we are finding F ratio, which is MSC divided by MSE. This is nothing but mean square of column divided by mean square of error. Like that, you have to find up to 7 when you calculate the F value, because only column affect this value. That's why we compare to it to the given value, and after that we go to result where we accept alternate hypothesis or null hypothesis. This is the way to find the one way or two way ANOVA. Up to here, I think you clear or not, Putti? Clear or not, Putti? These are the steps you need to follow for the second ANOVA problem, two-way ANOVA problem, but you follow some more step. It means only this question in one-way ANOVA problem, you have to effect only one column. But in two-way ANOVA problem, at least two features or two F ratio you should be calculated. It means if we are calculating up to column, but in two-way ANOVA problem, we have to calculate for the row and column also. For row, we are calculating our MSR divided by MSC. This is nothing but mean square of row divided by mean square of error. In column, MSC divided by MSC. These are the two factors which is affect the two-way ANOVA problem. These are the two steps which is affected. So this is called two-way ANOVA problem. Up to clear, Putti? Now you get the difference between the one-way or two-way ANOVA problem. Okay, if you have any doubt regarding from module 1 to module 5, you can ask. And please subscribe and share among with your friends. If anyone has doubt from module 1 to module 5, you can ask, I'll solve it. From module 1 to module 5, first you write the formula for each question, and first you write given in this question. This is the tips for passing. It means you have to write first formula and half of the question you have to write, because in VTU every step marking will be there. So you have to write step by step in every question. And please try to cover all the formula related to that module. Yes, they will give the formula book. No need to worry about it. Up to 3rd SEM, they will provide you formula book. In 4th SEM, I think they will not provide. Any other doubt, any other question, you can ask it. I will solve it. I already explained third module in my video. You go and check it from there. In the formula book, it will give you indexes from module 1, module 2, module 3, module 5. Every formula will be there. You go it and check it there. No need to worry about it. Just you know to how to use this formula. I think clear up to. No, they will provide you formula book. No need to worry about it. Up to third sem they will provide. After fourth sem or in fourth sem they will not provide you. So no need to worry about it. You just remember how to and where you have to apply the formula. Officially, they don't provide any notice about the formula book. They provide you formula book in the examination, so no need to worry about it. If you have any doubt regarding from module 1 to module 5, any question, any topic you want to understand, please tell me. I'll explain here. I think all is clear. Latent square, can you explain? Okay, I will explain one more time. Latent square. Am I audible to you guys? So let us understand what is latent square design. A latent square design is a statistical method used when three factors affect the result. Let us understand the difference between one-way ANOVA, two-way ANOVA, and latent square design. In one-way ANOVA, only one factor affect the result. In two-way ANOVA, at least two factors affect the result, and in three-way ANOVA, sorry, in latent square design, three factors affect the result. It means treatment, row, and column. This is the important rule we have to remember while in the examination. It means I already told you one way ANOVA, it means one factor affect the result. In two way ANOVA, at least two factor affect the result. In latent square design, three factor affect the results. Now you'll get the concept or not? Please respond me. Unique probability vector. Okay, I'll explain what is unique probability vector. First, we understand what is unique probability vector. A probability vector represents the probability of being in each state. It means pi equals to pi 1 p1 comma p2. This is for the unique probability being in each state. We can say that probability of p1 into probability of p2 which should be greater than or equal to 0. This is the condition for, or we can say that this is a rule for unique probability vector. And one more important thing is that p1 plus p2 should be equal to 1. It means probability of p1 plus probability of p2 should be equal to 1. This is nothing but the unique probability vector. Or we can write it as in terms of mathematical term, which is pi into p, which is equals to pi, and pi is nothing but we can consider x comma y. One more vector is there. So this is the condition for unique probability vector, and summation of pi of 5 which is equals to 1, I can be 0 comma 1 comma 2 comma 3 up to n. This is the formula for unique probability vector. Now you got it the concept or not, Putti? but find the value of x, y, z and confused. In what terms you are finding the value of x, y, and z? Can you explain it? Please, can you explain it? But find the value of x, y, z is confused. Oh, solving question. Okay, I'll explain one taking an example. X, y, and z. Where do x, y, z comes from? When a Markov chain has three states, steady state, probability vector is written as x, comma y, comma z. So this is nothing but pi of v equals to pi. So we can consider this. We already know x plus y plus z should be equal to 1. This is the condition. This is the probability condition. If two rules are enough for x and y, we can consider probability which is equals to 0.5, 0.3, 0.2, and this is 0.2, 0.5, 0.3, and 0.3, 0.2, 0.5. This is the probability we considered, and first we apply this cases where x comma y comma z multiply by 0.5, 0.3, 0.2, 0.2, 0.5, 0.3, and 0.3, 0.2, 0.5, which is equals to x comma y comma z. Up to here, you clear it or not, Putti? I am solving x, y, and z for steady state for Unix probability vector. Up to here, clear or not? Good morning, Sarita ji. If you have any doubt regarding this, you can comment here, I will solve it. So now we have to multiply x into, we can consider this is a row and this is a column. So x into 0.5 plus y into 0.2 plus z into 0.3. Like that you have to multiply this and compare for each x, y, and z. So let's solve it. For our equation 1, this is nothing but 0.5x plus 0.2y plus 0.3z should be equal to x. It means x into 0.5, y into 0.2, z into 0.3, which should be equal to x. Like that 0.3x plus 0.5y plus 0.2z, which should be equal to y. This is our equation first, this is our equation second, and now 0.2x plus 0.3y plus 0.5z should be equal to z. This is our equation third. Now solve it. And first equation we already know, this is x plus y plus z equals to 1. So now we have to find the value of x, y, and z. So from equation 1 and from equation 2, we can take the value of x, which is x minus 0.5x equals to 0.2y plus 0.3z, which is equals to 0.5x equals to 0.2y plus 0.3z. Up to here you get it the concept or not, Putti? You can solve these three equations with the help of this equation and you will get the value of x, y, and z. Clear or not, Putti? Okay. If you have any doubt regarding this, please comment. Okay, if you have any doubt from module 1 to module 5. Okay, after this step I want, okay, I'll solve it completely, huh? Don't worry. So from second equation, y minus 0.5y, which is equals to 0.3x plus 0.2z, which is equals to 0.5y equals to 0.3x plus 0.2z. This is our another equation. And already we know that x plus y plus z equals to 1. So for steady state, we can say that x equals to y equals to z. So x plus y plus 1, z equals to 1. So we can consider this is equal to 1. So 3x equals to 1. Then x equals to 1 by 3 for the steady state. So we can say that x equals to y equals to z equals to 1 for the steady state. I think up to clear or not, Putti? This is 1 by 3 for the steady state. Clear or not, Putti? Yes, if you have any doubt regarding from other knowledge, please comment. Alright everyone, we will stop here for today live session. I hope this overall quick revision help you understand the important concept of VTU third sem maths BCS 301, especially where and how to apply the formula. VTU math is not about solving everything, it's about writing the right step in the right order. In the exam, stay calm, read the question properly, write the formula clearly, and always give a final conclusion. If today's session cleared even one doubt of yours, this live has done its job. Please revise today's notes once again before the exam, especially probability, Markov chain, ANOVA, and latent square. If you still have doubts, you can drop them in the comment or message. I'll try to best the help to you. So thank you for watching and all the best for your exam. Believe in yourself, you will prepare well. Take care, stay confident. I will see you in the next class. Thank you.